Hello and welcome to our physics presentation about the effect of amplitude on mechanical waves. To begin with, I will talk about medium and speed since this is involved in our project. As we know, water waves are mechanical waves, which implies they must travel through a medium. The medium can be solid, liquid, or gas, and the wave speed is determined by the material properties of the traveled medium. In some cases, waves travel at a constant speed. For our project, the medium in our experiment is liquid, and that is the water in the pool. To complete our project, a droplet was dropped into the pool and recorded the wave that followed. As can be seen on the video, a ripple effect was made. We then measured the dolphin as a point of reference for the video analysis tool, and the picture on the bottom right is where the points were plotted following a specific crest on the wave. Here is the result of the first video, the velocity that resulted being 0.2631 meters per second. Our first wave observed is also shown to be a transverse wave. The displacement of particles in this type of wave is perpendicular to the direction of wave propagation. The particles do not move with the wave. Instead, they oscillate up and down about their individual equilibrium positions as the wave passes by. Applying this to our video, the water particles are vibrating up and down while the ripples move horizontally across the water. The ripples propagate horizontally while water particles vibrate perpendicular to the wave propagation direction. For our second video, we used two rocks and were dropped at the same time to show two waves passing through each other. The point of reference stayed the same for this recording, which was 0.1626 meters. The picture on the bottom right once again shows where the points were plotted to obtain the position versus time graph and determine the velocity. This is our resulting graph for video 2, where the velocity of the right wave was 0.2254 meters per second. Now, our second wave is an example of superposition. Superposition simply means that when two or more waves come together, the disturbance will be equal to the sums of each individual disturbance. This is something that can be seen in our video, since once both waves overlap, it will be equal to the sum of both individual waves. Both waves observed are periodic waves, which means they show a repeating and continuous pattern for several cycles. Once again, it was observed that the first wave had a velocity of 0.2631 meters per second, while the second wave experienced a velocity of 0.2254 meters per second. The difference between both waves is 0.0377 meters per second, which is a slight difference. Overall, this concludes that since the speed of both waves are slightly different, almost the same, it shows that the speed of the wave does not depend on the amplitude of the wave. And that concludes our presentation. Thanks for watching.